Hello and welcome to the Practical Linux Malware Development course. My name is Nemuel and I shall be your instructor throughout the course. A bit about myself. As said earlier, my name is Nemuel Wenaina. I am a security researcher and software engineer, and if you'd like to get in touch, view my work, or learn more about myself, you can check out all these links that are listed here. I'm available on LinkedIn and Twitter. You can check out some of my articles on Medium as well as some of my projects on GitHub. Now, over the past couple of years, there has been a tremendous spike in malware targeting Linux platforms, and the major reason for that is that companies are increasingly migrating to the cloud. Now, when you get to the cloud, it is Linux that dominates, with about 90% of the cloud running on Linux. There's a few reasons for that, and we have some of them right here. Linux is open source, it has better security, and it allows for extensive customization. Now, attackers are after data, and so, as you might have already guessed, they are going to adjust their tactics and techniques to suit Linux platforms, hence the increase in malware targeting Linux platforms. So what are we going to be developing? This is a practical course, and therefore we are going to actually create our own malware from scratch. We are going to be developing a remote access Trojan using the Go programming language, and later on create a command and control server for the same using Python. Now, our malware is going to have all these capabilities to take a screenshot, file upload, file download, shell command execution, and we shall finally take a look at persistence. Now, a disclaimer here, I will not be responsible for any irresponsible use of the knowledge and skills gained in this course. I urge us all to work towards making the internet a safer place. In the next video, I will do a demonstration of the final project that you and I need to have by the end of the course. See you there. Hello and welcome back. As you can see, with me here are two terminal windows open, and on one I'm going to run the command and control server, and on the other window I'm going to execute the malware. So for the command and control server, the command is python 3 space server.py, and as you can see, it's listening for incoming connections, and on the other window I'm going to execute the malware, so /Trojan, which is the name that I've given it. And as you can see, as soon as I hit enter, we receive a connection on our command and control server. Now, with this prompt right here, we can type in any command and receive the results. So for example, who am I? And we get back the username of the currently logged on user. pwd gives us the current working directory on the target machine. ifconfig gives us the network information on the target machine. So all of this entail shell command execution, and the other feature of our malware is file download. Now, what that means is that we can transfer files from our target machine onto our command and control server. So we can do a file listing, and as you can see, we only have our malware. So I'm going to navigate around the file system using the cd command. So cd .. and I'm going to go to the documents directory. And if we do a pwd again, we can see that we are actually in the documents directory. Let me do a file listing, and guess what? We get a secret.pdf file. So the next thing we are going to do is download this file onto our command and control server for viewing, and the syntax for that is download space followed by the name of the file, in this case secret.pdf. Hit enter, and as you can see, we get a notification here, file saved successfully. Let's open our command and control server location, and as you can see, we have a new file right here called secret.pdf. Let's open it, and as you can see, we are able to view its contents. The other feature we are going to try out is file upload. Now, this is the opposite of file download, and it essentially means transferring a file from our command and control server back to the target machine. The syntax for that is similar to the one for downloading a file. So it is upload space followed by the file name. And before I do that, I'm going to just do a listing of the files that we have right here. And so the one that we are going to do for this is the config file. So I'm going to simply do upload space config, hit enter, and we get a notification that the file has been uploaded successfully. To confirm that, we can simply do a listing. And as you can see, we have that file on the other side, which is our target machine. The other feature that we are going to see is taking a screenshot. Now, the command for that is simply screenshot. And after typing that, I'm going to hit enter, and we get a notification that the screenshot has been saved successfully. Again, we check where we have our command and control server. And after opening it, we are able to see a screenshot of our target machine, which in this case is just our desktop. I'm going to close that. And the final feature is persistence. Now, the command for that is persist, and hit enter, and we get a notification that the persistence has been established successfully. What this means is that whenever we reboot whenever the target reboots their machine, we will still be able to get a shell on their machine because our malware will automatically start. Finally, if we want to close our connection to the target machine, we can use either Q or the quit command, and the connection will be closed. Our malware will also terminate. So we have our malware running right here. I'm going to do quit, hit enter, and as you can see, we get a message here, closing connection, and our malware stops executing. That is it, guys, and this is what we are going to be creating throughout the course. See you in the next video. Hello and welcome back. In this lecture, we are going to go through the environment setup that you will need in order to successfully follow along the course. So what are we going to need? One is a Linux-based operating system, e.g. Ubuntu, Kali Linux, or Parrot. We'll also need a code editor, which is where we are going to be writing our code, for example, Visual Studio Code. We will also need the Go compiler, since we are going to be using the Go programming language, and also a Python interpreter, since we will also use Python. So where do we get all of these? So with me here open in my browser is Ubuntu's website, where you can go and get the Ubuntu operating system. And just in case you do not have a Linux operating system on your bare metal, you can simply get a virtualization software, for example VirtualBox, download it and install it. Then you can get a Linux distribution and run it on top of the virtualization software. Next is a code editor. I'm personally going to be using Visual Studio Code, and this is the website for the same, code.visualstudio.com. And as you can see here, you have a download button as well as here. Next is the Go compiler. You simply head over to this URL, https://go.dev/doc/install, and here you'll find the installation instructions for the Go compiler on all platforms. So for our case, we are working with Linux, and going to the Linux tab, you can find all these instructions right here in order to install Go. Finally, we need a Python interpreter, and here is Python's website, www.python.org/downloads, and you can simply download the latest version right here. That is it for this lecture, guys, and I will see you in the next one. Hello and welcome back. In this section, we are going to be developing the remote access Trojan, and for the first lecture, we are going to set up the project and write down a plan. So I'm going to open my terminal right here, navigate to the desktop, which is where I'm going to be working out of, and create a directory that I'm going to call malware, which will contain our malware's source code, and I'm going to open it in my code editor, which is Visual Studio Code. Now, as you can see, the command for that is code space followed by the name of the directory, in this case malware. Once that is done, I'm going to create a file in our directory. I'm going to call it plan. It is going to contain a plan for developing our malware. So the first thing we are going to do in our malware is to connect back to the command and control server, in short C2 server. And once we have done that, we are going to start to receive incoming commands from the C2 server. And with the command, we'll be able to perform the desired action. Now these actions, one of them is to terminate the connection, and the commands for that will be either Q or quit. So this means terminate the connection. The other command we might expect is the CD command, with an optional target directory, which means change directory to the target directory. The other one, we have file upload, as I had mentioned in the first section, file download, screenshot. We also have persistence, and we have shell command execution. So we'll be able to perform all of this based on the command that we have received. Shell command execution. Okay. Now that out of the way, I'm going to create the file that will contain our code, and I'm going to call it main.go. Note that the .go extension is because we are working in the Go programming language. Now for a start, I'm going to create a simple Hello World program that will help those of you that are new to the language to understand the basic structure of a Go program. Now the first line in every Go file that you'll create has to be a package declaration. So every file that you create in the Go programming language has to be part of some package, and in our case, our program will be part of the main package. Now the reason for that is that you're going to be actually building and executing our file. Once we have done the package declaration, the next thing we need to do is to import any packages that we are going to be using in our code. So this is our Hello World program, and that means that we are going to be printing out the text Hello World on the terminal. So I'm going to import a package for standard input output, and that is FMT in Go. And once that is done, we are going to create our main function. Now, if you have worked with other languages like C and C++, you understand that execution starts from the main function. The same applies for Go, and so I'm going to create the main function right here, func main. The func keyword is for the creating functions, and inside of here we are going to use the print line method of the fmt package, which simply prints out a line of text, and in here we are going to type in our string. And that is it for our first program. Now, to execute it, I'm going to open the terminal, and once that is done, we have a number of options to run our code. So first, we can build our program and then execute the binary. So as you can see, we get another file here, which is our binary, and then we can execute that and we get back our output, or we can directly run our code. So the command for that is go run followed by the name of the file, that is main.go, hit enter, and we still get the output. Now, in the next video, we are going to get started with the first step of our plan, which is to connect back to the C2 server. See you there. Hello and welcome back. In this video, we are going to create a function that will allow us to connect to the command and control server and get back a connection object. For that, I'm going to import an extra package up here called net that is used for network operations in the Go programming language. After that, I'm going to create a function at the bottom here, and I'm going to call it connect home. And from this function, we are going to get a connection object, and inside the curly braces, we are going to have the logic. So to get the connection object, we are going to use the dial method of the net package, so net.dial. And as you can see, it receives two parameters, one being a network and the other address. So for the network parameter, we are going to use TCP, which is short for Transmission Control Protocol. And after that, we have the second parameter, which is our C2 server address. Now, as you can see, we have not yet declared it. And so I'm going to come back to the top here and create a constant since it's not changing. And I'm going to call it C2. It's a string. And we're going to assign it the IP address and port of our C2 server. Now, for testing purposes, I'm going to use the localhost IP, so 127.0.0.1, and a port of 1234. Once that is done, as you can see, it can now be recognized down here. And now we can store the values that we get from this method in variables. So it returns two values. One is a connection object and the other is an error. So con, I'm going to call it that, and err are equal to that. And once we have that, we can return the connection object. However, it is not all the time that our command and control server will be up and running by the time our malware executes. So for the case when our malware executes before the command and control server starts to run, we want to be able to handle that situation as well. So what we are going to do is that we are going to check whether we are getting an error from this method, and if we do, we are simply going to have our program sleep for a few seconds and then try to connect back again. So for that, I'm simply going to check the value that is stored in this variable. So if error is not equal to nil, that means you have actually gotten an error. What you are going to do is that you are going to take a few seconds and then try to connect back again. So time.sleep, or the package has already been imported up here. And as you can see, it takes back the duration in seconds. So for that, we are going to have time.second, which is a constant, multiplied by 30. So that is 30 seconds. And after that, we are going to try to connect back again. So for that, we are simply going to return the method right here. So once that is done, we need to get back this connection object and store it in another variable that we will use to interact with the command and control server. So we are done with this line right here. I can also remove this FMT package. And right here now, we can initialize a variable with the result from this function. Now that is it, guys, for this lecture. And in the next one, we will move on to start receiving commands from our command and control server. I will see you there. Welcome back. Having been able to connect to the C2 server in the previous lecture, in this one, we are going to work on receiving commands from the C2 server. For that, we will need an extra package called buff.io, which is short for buffered input output. And once we have that imported, we are going to create a loop in our main function, which will allow us to continually receive commands from the C2 server. After that, we are going to use the new reader function of our buff.io package. So .newReader. And it takes in a parameter, which in our case will be the connection object. And what this function returns is a reader struct on which we can use the read string function. So this function rather, is going to return a string, which in our case will be the command from the C2 server, and an error in case of an error. As you can see, it takes in one parameter, which is a delimiter, and for that we are going to have a new line character. So if we do not include this delimiter right here, we are going to keep receiving commands from our C2 server, and our malware will just get stuck right here. However, with a new character, this line is going to stop whenever we encounter a new line character and proceed with execution. So we are going to store these values in variables, so cmd, which is our command. I'm going to ignore the error for now. And once we have that, I'm going to proceed to remove any trailing spaces in our command. So I'm going to use the strings packets, and I'm going to use the trim space method on the cmd variable. So the first thing we do is receive our string from the command and control server, that is through the connection object, and after that we remove any spaces in our command. In the next lecture, we are going to work on creating a function that will make it easier for us to continually send back our results to the C2 server. I'll see you there. In the previous lecture, we created a loop and we were able to successfully receive commands from our C2 server. With our commands, we can now perform, or rather our malware can now perform the intended action and then give back the feedback to the C2 server. Now we are going to do that a number of times since we have different actions that our malware will be performing, and therefore, since we are going to be doing it several times, it is wise for us to have a function that will be doing just that. So I'm going to create a function for that in this lecture, and I'm going to call it sendResp, short for send response. And what it is going to be receiving as parameters is the connection object, like that, and the other thing is the message, which is a string. So the first thing is our connection object, which is what we are using to communicate with our C2 server, and the other parameter is the actual message that we are sending back to our C2 server. Inside here, we are going to have just one line, which is fmt.fprintf. What this function allows us to do, as you can see, let me first import the package. So fmt. And as you can see, it formats according to a format specifier and writes to the writer that we provide. In our case, that writer is our connection object. And then we are going to have a format string, in this case %s, s in this case for string, and that parameter will be the message. Now that is it, and so from now onwards, whenever we'll be sending back our feedback to the command and control server, we are simply going to invoke this function with our connection object and our string. That is it, and I'll see you in the next one. We are now going to start handling the various commands that you're going to be expecting from our command and control server, and the first one will be the queue or quit commands, which means that we terminate our connection. So we are going to check for that. We are going to use an if-else statement for that. So if cmd, which is the variable containing the command from the C2 server, is equal to either queue or cmd is equal to quit, then what we are going to do first is send a response or a notification to our command and control server that we are closing our connection. And once we have done that, we can now close the connection. So that is con.close, that is closing the connection object. And after that, we are going to break out of the loop. That is it. And in the next one, we are going to work on the cd command, which is for changing directories. I'll see you there. To handle the cd command and actually all other commands that we are going to be working with from now on, we are going to actually create an else if statement for each. So in this case, for the cd command, I'm going to do else if, and I'm going to check that cmd and the first two characters of the cmd variable are equal to cd. Once this condition is satisfied, then you can perform whatever operation we want regarding the cd command. Now for this case, we have two possible commands. One is where we have just the cd command, and the other is where we have cd followed by a target directory. So we are also going to check for that, and that means you are going to have a nested if-else statement, and you are going to start with the first scenario. So we are going to check if cmd is directly equal to cd, then what you are going to do is get the current working directory and send that back to our server. So CWD, short for current working directory, and an error will hold the result that we get from the get current working directory method of the OS package. Now it's not imported, so I'm going to import it first. And right here, you're going to have this method, get current working directory. Get working directory, sorry about that. And as you can see, it returns the directory, which is a string stored in this variable, and an error, which we store right here. Now we're going to check for the error. So if error is not equal to nil, then we are actually going to return that error. So send to our connection object, through our connection object, the error. I'm going to use the error function, which is actually going to take our error type and convert it to a string. Otherwise, we are going to return the current working directory. So send through the connection object, the current working directory. And that is it for the first scenario. In the next case, or the other case, what you are going to do is split the command that we have received from our server into two. One will be the cd command, and the other will be the target directory. For that, we are going to use the split method of the strings package. And as you can see, it receives two parameters, one being the string and the other a separator. And as you can see, it returns a slice of all the substrings. So we are going to be splitting CMD using white space, and you are going to see what it returns. So it returns the slice of strings as mentioned before, and what we want is the target directory. So that will be the first one, or the second parameter, sorry, and you're going to store that in a variable called target underscore directory. And once we have the target directory, we are now going to try and change into this directory. For that, we are going to use the change directory method or function of the OS package and provide it as the parameter right here. And as you can see, this method returns an error. So you're going to store that in a variable, error, and you're going to check whether it's nil. So we can just include that together in our if statements. Error is not equal to nil. Then you're going to send, just as we have done up here, we are going to send the error message that we get. And if we are able to change the directory successfully, then you can simply send back that directory. So else, through the connection object, and you're going to send the target directory. That is it, guys. And in the next one, we are going to be working on file upload. I'll see you there. Welcome back. Now for file upload, and for that matter file download as well, we are going to do it in a number of steps, and I have listed them down here. So the first thing that we are going to do will be to read the file that we want to transfer in binary, and once we have its binary contents, we are going to convert that into a base 64 string. Once we have the base 64 string, we are going to generate a message that will basically be a concatenation of the file name and the base 64 string, and send that over the network to the other machine. Once we have received it on the other end, we are going to do the reverse. And so the first thing that we are going to do will be to split the string using the colon as the separator. Once we do that, we are going to have two values. One is the file name and the other the base 64 string. And so we are going to decode the base 64 string to get the contents of the file in binary. With that, we can simply write it to the file. And of course, we have the file name since it was part of the message, and we will have replicated the file on the other machine. In the next lecture, we will now get down to writing the code for file upload, and I will see you there. On to the code now. In the previous video, I had mentioned that we shall be including a colon in the message that we shall be sending to the other machine, bringing together the file name and the base 64 string. So for our condition right here, I'm simply going to check if our CMD string contains the colon. So I'm going to use the contains function of the strings package. So if string dot contains a colon, and if this condition is true, we are simply going to split this CMD string. So that will be strings dot split CMD and the colon as the separator. This should be capital S. And this method will return a variable which will contain the result, so that I'm going to call it temp. And once we have that, we can now begin the process of saving this, whatever we have received, into a file. Now for that, I'm going to create a separate function, and I'm going to call it save_file. And it is going to take 2 arguments. So one will be the file name, which will be a string, and the other will be the base64 string, which will be a string as well. And to verify the success of writing our file, whether or not we have been successful, I'm going to return a boolean, which is either true or false. Now within this file, there's something I would like us to do first. Now, when we receive the base64 string on the other machine, which is the machine that will be running our malware, it will be in this format, B, and within single quotes, we will have our base64 string. Now, the reason it will be like this is that before sending it from the server, it will be encoded, and that is why it will come here in a binary form. So, to get our base64 string, which is what we want, we are simply going to omit this B and this single quote at the start and the single quote at the end. So I'm going to create a temporary variable right here, and that we are going to start from the second index of our base64 string all the way to the second last character of our base64 string. So length of the base64 string -1. Once we have that, we can now decode it, and for that we'll need to import the base64 package. So encoding base64, and right here we're simply going to do base64.std encoding.decode string temp, and this method will simply return the bytes that are represented by the base64 string. So I'm going to store that in a variable, and of course, and for this we are going to ignore the error. And once we have that, we can now save it to a file. Now for that, you're going to use the read file function of the OS package. And as you can see, so the write file function. And as you can see, it takes 3 arguments. So one is the name, the other is the file contents, which are bytes, and finally the permission. So for the name, we're going to use the file name that we received. And then the content will be simply the content. And finally, the permissions, I'm going to use 0644. So that is read and write, and then just read and read for the group and other users. Now this function returns an error, which is what we are going to check for. So if error, an error not equal to nil, which means we actually got an error, we are going to return false, indicating that the process was not successful. Otherwise, you are going to return true. Now back to our else if statement, we are simply going to do if save file, and it takes 2 parameters as we have shown down here. One is the file name and the other is the base64 string, and the file name is the first value in our temp variable, and the base64 string is the second value in our temp variable. Now if this is true, that simply means that the process was successful. We are simply going to send back a response to the server that the file was saved successfully. So file uploaded successfully. Otherwise, we are simply going to send a response to the server that there was an error uploading file. Now that is it for file upload, and in the next one, we are going to work on file upload. I'll see you there. Now for file download, we expect our command to have this format: download space followed by the file name. And so in our check for this command, we are simply going to split the cmd variable using a white space and check whether its first value is equal to download. So else if strings dot split cmd using a white space, and you're going to store that in a temp variable, and you're going to check whether the first value in the temp variable is equal to download. And if this condition is true, then you can proceed to read the file and send it back to the server. Now for this case, we are going to first start by checking whether the file exists, since the command might be pointing to a file that does not exist, maybe a typo or something like that. So I'm going to create a file right here called file exists, and it is going to return a boolean. So it's going to receive the name of the file, going to return a boolean, and right here we are going to use the start function of the OS package. And as you can see, it returns a file info describing the named file. So if the file does not exist, then you'll definitely get an error, and that is what we are going to use. So if error, because this is what we need, and error is not equal to nil, then you're going to return false. Otherwise, we're going to return true. Once we have confirmed that a file exists, the next thing we are going to want to do is to read the file and then send back the base64 string. So I'm going to create another function that will receive the name of the file, read it, and return a base64 string of its contents. So func file underscore b64 file string, it is going to return a string, which is the base64 string. And right here, we are going to first read the file using the read file function of the OS package, and then we are going to return the base64 string. So using the base64 package .std encoding .encode to string the content. Now once we have returned the file base64 string, we want another function which will now have all this brought together. I can see we have an error right here. So this should be a relational operator. Then I'm going to create another file that I'm going to call getFile, another function, sorry, called getFile, receiving the file name, which is a string, and it is going to use these two functions. So the first thing it is going to do will be to check whether the file exists. So if the file does not exist, then we are going to simply return. We're going to be returning a string here. So return file not found. Otherwise, we're simply going to return base64 string of the file. However, as earlier on mentioned, in our plan for file transfer, we'll simply be sending the file name, a colon, and then the base64 string. So you're going to do the same right here. So I'm going to have the file, that is the file name, plus a colon and the base64 string at the end. Now with this function, we can simply now call it right here. So you're simply going to do send response through the connection object to our server, get file followed by the file name. In this case, it is the second value of the temp variable. And that is it, guys, for the download functionality of our malware, and I'll see you in the next one. In the previous video, we actually made a couple mistakes, and that is what I'd like us to fix in this short video. So right here, we are supposed to pass the name of the file to the getFile function, and it is actually the second value in the temp variable. I used 0 instead of index 1, and so that is what we should have. And then down here, it should be error not equal to nil. Only in that case should we return false from the file exists function. That is it, and I'll see you in the next one. Welcome back, and for this video, we are going to add the functionality to take a screenshot of the target machine and send it back to our server. So the check for that will be simply if our CMD variable is exactly equal to the screenshot string. So else if CMD is equal to screenshot, and if the condition is true, then we shall proceed to take a screenshot and send back a base64 string of the file to our server. Now for that, I'm going to create a new function at the bottom here. So func, I'm going to call it check_screenshot. and it is going to return a string which will be the base 64 string of the file. Now for this, we are going to need a third-party package which is available on GitHub. I have opened it here. And so to use it, we will first have to install it, and the command for that is go space get followed by the URL of the package. Now as you can see right here, it is a Go library to capture desktop screens, and it supports multiple displays, that is for Windows, Darwin, Linux, and the rest. So we are going to have this URL. Let me copy it. And I'm going to paste it right here. And before hitting enter, there's something else that we need. Now I am using Go version 1.19, and since Go version 1.11, a feature was introduced that requires us to have initialized a module in our project in order to be able to install other packages. Now I do not want to do that, and so to disable that feature, you're just going to use Go 111 module equals to off space and then our command. Hit enter, and the package should be installed in your project. It's complete, and now we should be able to proceed and import it up here. So let me import it. And once that is done, we can take the example that we have right here. So the first thing that we do with this package is to get the coordinates of the top left and bottom right points of our screen. Once we have that, we will then proceed to capture the rectangle that is bound within these coordinates and then save that to a file. And of course, now in our case, we shall send back a base 64 string of the file to our server. So let us do that. The first thing will be to get the coordinates. So get display bounds, and it takes a display index which I am going to give as 0. Now the reason I'm giving it as 0 is so that we can use the default monitor. It returns an image.rectangle, and I'm going to store that in a bounds variable. And once we have that, we can now proceed to capture the rectangle within the bounds. So screenshot dot capture rect, and they pass our bounds variable. And we are going, it returns two values, an image and an error. So I'm going to store those in variables. So img, I'm going to ignore the error for now. And once we have already captured that, we can now proceed to write that to a file. Now I have not created a file, so I'm going to do that right now using the OS package. So os.create, and I'm going to call our file wallpaper.png. Now as you can see, this function returns two values, an os.file pointer and an error. So I'm going to store those ones in variables. And after that, we can proceed to save our img variable to the file. Now to do that, we will need another package called the png package, and we import it as follows: image/png. And then down here, we shall use the encode function of the png package. So png.encode, and it takes a writer and the image. So our writer will be the file, and the image will be our img variable. Now at the top here, there's something I would like to add. That is using the defer keyword and file.close. Now what this does, the line defer file.close, is that it ensures that the handle to our file, which we have opened right here, will be automatically closed upon the ending of this function. Let us proceed. Now that we have already saved our image to the file, we can now get a base 64 string of its contents. We already have a function for that called file_b64, and so I'm going to call that function right here and supply the name of our file, which is wallpaper.png. And as you can see, it returns a string, which is the base 64 string, and I'm going to store that in a variable. And before returning it, there is something else that we are going to do. Now, if the target machine or the user of the target machine by any chance comes across this image, they might suspect some malicious activity on their system. So before sending back the base 64 string, we are going to delete this image to cover our tracks. So I'm going to use the remove function of the OS package for that and pass in the name of the file. And once we have done that, we can now return our base 64 string. With this function, we simply need to do one more thing in our main function, and that is to send back the response of that function to our server. So send underscore resp through the connection, the result of the take screenshot function. I can see an error right here, so let me check where that is coming from. Okay, so this should not be here. Let me remove it and bring it up here, like that. And that is it, guys. In the next one, we shall work on persistence, that is to ensure that our malware keeps running even after the machine gets rebooted. I'll see you there. Welcome back. And for persistence, we are going to directly compare the cmd variable and the string persist. So else if cmd is equal to persist, and if the condition is true, then we shall proceed to implement persistence on our target system. Now for that, I'm going to right here called persist, and it shall return a string which shall notify us of whether or not the process has been successful. That string is what we shall later on send back to our server. Now, before we actually implement our persistence functionality, I would like us to understand the kinds of persistence that we can achieve on a system. So there is two kinds of persistence, one being system-wide and the other being user-level. Now, system-wide persistence basically means that our program will start regardless of the user that logs into the system. However, this requires root privileges in order for us to be able to implement it, while the other one, being limited to a specific user, does not necessarily require root privileges. Now for our case, we are going to work with user-level persistence, since it is not all the time that we will have root access to a system. So how are we going to implement it? We have a number of steps right here, and the first one will be to create a file. For example, a file named persist in the tmp directory, and once we have created the file, we shall proceed to write something to the file. As you can see, the string that we shall be writing to the file follows the format at reboot, followed by the path to the executable that we want to be started every time the system is rebooted. And of course, please do not forget a new line character at the end of the string that we write to the file, because if you omit it, you'll actually get back an error. Once we have written this string to our file, we shall proceed to execute the crontab command followed by the file. So user bin crontab, which is where the crontab executable is located on the system, followed by the name of our file. Now that we have understood that, we can proceed to implement it in our code. So the first thing I'm going to do is to create a variable called filename, which will hold the name of the file, where we shall have that instruction. I'm going to call it persist. And once we have done that, I will proceed to create the file. So I'll use the create function of the OS package and pass in the name of the file. And as you can see, it returns the file and an error. So I'm going to store that in a variable. And once we have created the file, we can proceed to write the string to the file. However, as you can see right here, we need a path to our current executable, and therefore we are going to start by getting that and storing it in a variable. So I'm going to call it exec_path, and to actually get the path to our executable, we are going to use the executable function of the OS package, and as you can see right here, it returns the path name of the executable that started the current process, which in this case will be our malware. It returns a string and an error. So I'm going to store that in a variable called exec_path and ignore the error. And once we have that, we can now proceed to write this command to the file. So for that, we are going to use the fprintf function of the fmt package, which allows us to write formatted strings to a file. So the first argument will be file. The second one will be our string, so attribute, and the format specifier for a string, which will be substituted by exec_path. Now, once we have done that, the final thing that we are going to do is to execute this command, and for that, we'll need to import something extra up here, which is os/exec, and this basically allows us to execute shell commands in our program. So once we have imported that, we can proceed to do exec.command. And as you can see, we have two parameters right here. One is the name of the command that we want to execute, followed by any number of arguments that we shall pass to our command. So our command will be user/bin/crontab, and the second value right here will be our file name. Now, to get the results, which is what will enable us to understand whether or not our process has been successful. We shall get the output right here, combined output rather. And as you can see, this function returns the command, runs the command and returns its combined standard output and standard error. So our focus will be the error, so that if the error is not nil, that we will know that our process was not successful. And if it is actually nil, then we shall know that our process was successful. So we are going to store this in variables. And then we shall proceed to check if our error variable is nil. So if error is not equal to nil, then we shall return back the error. So return, or rather, you can just return a string that persistence, or the error establishing persistence. And if the error is nil, then you can simply return that persistence has been established successfully. And as you can see right here, I almost forgot a new line character, so let me add that. And that is it. Once we have written down our function to achieve persistence, we can get back right here and send back our response to our server, the result of this function, so persist. So as you can see, the steps were to first create a file, then proceed to write to the file this instruction attribute followed by the path to our executable, and finally a new line character. And after we have done that, we proceed to execute the command crontab followed by the name of the file. And if it is successful, then we proceed to return a string that persistence has been established successfully. And if we get an error, then that means that we are not able to successfully establish persistence. That is it, guys. And in the next one, we shall now finish up by executing shell commands. I'll see you there. Welcome back. And before we finish up with shell command execution, there is two small things that I would like us to change. And one of them is right here, where I typed in etc instead of tmp. So it should be tmp, that is the temp directory. And then something else that I would like us to add is, if you can remember in the screenshot section, once we were done with taking the image and having a base 64 string of the file, we proceeded to delete it from the system in order to cover our tracks. I would like us to have the same thing up here. So we are going to delete the temp/persist file once we are done with it. And that will just need one line. So os.remove file name. And that is it. Now on to shell command execution. Now this is the final case that we are going to be handling here. And so we are going to just have an else statement. And within our curly braces, we shall handle the shell commands. So I'm going to create a separate function for it as well. So func, I'm going to call it exec_command, and it is going to take the command, which is a string, and return back a string, which will be the result of executing the shell command. Now for that, we are going to use the exec package, which we had imported in the previous lecture, .command, and you're going to pass in the command, that is the cmd variable, and get its output. So as you can see, the output function right here will run the command and return its standard output, and any returned error, which will be type exit error, we are going to basically store the result of this function in two variables. One of them will be the output, and the other will be an error. After that, we are simply going to check if error is not equal to nil, meaning we got back an error, and that is what we are going to return. So return error in string format. Otherwise, we are simply going to return the output. So else return string output. The reason we are doing this is because right here it is returned as an array of bytes, and so we have to cast it into a string before returning it. Once that is done, we are going to have just one line up here. So send response through the connection back to the server, the result of exec_command cmd. And that is it, guys. So we are done with our malware, and in the next video, we shall put it to the test using a tool called netcat. See you there. Now, to test our malware, with me here are two terminals, and on one of them, I'm going to start a netcat listener on port 1234, and on the other terminal, I'm going to start our malware. So let me start our netcat listener. So nc nlvp, that is for no DNS resolution, listen, verbose, and P for the port, which is 1234. Hit enter, and as you can see, it is listening on our host on port 1, 2, 3, 4, and on the other end, we are going to start our malware. So the command for that will be simply go run followed by the name of the file. But before we hit enter, remember to disable the module feature. So go 111 module equals to off space and then hit enter. Now, as you can see, immediately we start our malware, we receive a connection on the other end, and now we can start to interact with our target machine. So let us try who am I, and we get back the username of the currently logged on user, which is namecxt. Let us try pwd, and we get back our current working directory, which is desktop/malware. Now all these are shell command execution. We can even try ifconfig, and you get back the network information. Now let us try the cd command. It does the same. It gives us the current working directory, and we can try to change to another directory. So say cd home namecxt/desktop. Hit enter, and as you can see, we get back the directory. And if we do pwd, we get our current working directory as the desktop. Now, as you can see right here, the output is not formatted so properly, and that is why we will actually need a custom server for our malware. However, that aside, we can see that our malware gives us back the feedback that we want, and we can even proceed to try the screenshot command. Hit enter, and we get back a very long string, which, as you might have guessed, is a base 64 string of the desktop's image or screenshot. The other thing we might want to try to do is to download a file. So I'm going to navigate to our malware directory, do ls, and we can try to download the plan.txt file. So download plan.txt, and perfect. Just as we programmed our malware to do, it gives us back the name of the file, a colon in between, followed by a base 64 string of the file's contents. That is it, guys. Congratulations on making it this far, and in the next section, we shall embark on developing a custom server for our malware. I'll see you there. Hello, and welcome to this section in which we are going to be developing our server. So I'm going to create a folder as we had done in the previous section, and I'm going to call it server. And after that, I'm going to simply open it in Visual Studio Code. So let me open it. And just as we had done in the previous section, we are going to start by creating a plan. So I'm going to create a file called plan right here. And right here, we are going to list the steps that we shall follow. So this being our server, the first thing that we are going to do will be to listen for incoming connections. That is from our malware. And once we receive an incoming connection, we will enter into a loop in which we shall be continually receiving input from the user. So this input is basically the commands which will then be sent to the malware, executed, and the results sent back. So in the loop, the first thing we do is take input from the user, then send that to the malware, and then receive the results. So this is basically what we are going to be doing. And in this loop, since we have a lot of capabilities in our malware, we shall have a series of if-else statements which will enable us to handle the different possible commands. In the next video, we shall get started with the code, and I'll see you there. Welcome back. So I'm going to create a new file here, that is a Python file. I'm going to call it server.py, the py extension because it is a Python file. And right here, we're going to start by importing some things from the socket module. So the socket module, for those of you that may not know, basically allows us to perform network operations in Python. So from socket, import socket, afinet, do not worry as I'll explain each and every one of these, and sockstream. Once you have imported these, we are going to start by creating a socket object. So s equals to socket, and it takes two, we are going to pass two parameters to it, one being the address family and the other being the socket kind. And those two are what we have right here. So afinet basically indicates that we are going to be working with the IP version 4 addresses. So afinet, and sockstream basically means that we are going to be using the transmission control protocol or TCP. Now once we have done that, we are going to bind our socket to a specific IP address and port which we are going to be listening on. To do that, we are going to use the bind function of our socket, and it is going to take a tuple which will contain the IP address and the port. Now, since we are running this on our local machine, we are going to use the loopback address, which is 127.0.0.1, and for the port number, we are going to use the same one we had in our malware, which is 1234. Once we have done that, we can now start listening for incoming connections, and the function for that is just s.listen. And we can even print out a notification right here that we are listening for incoming connections. And that is it, guys. We have our listener up and running now, and in the next one, we shall write the code for accepting a connection from our malware. I'll see you there. Now, before we work on receiving incoming connections, there's something that I would like to add here, and that is a 1 to our loopback address, which I had forgotten in the previous video. That done, let us now work on receiving connections from our malware. For that, we are simply going to use the accept method or function of our socket, and so that is s.accept. And as you can see, it returns a tuple which contains the connection object that we shall be using to interact with our malware and the address of the machine that has connected to our server. So I'm going to store these two values in two variables. One I'm going to call con, short for connection, and the other addr, which is short for address. Once we have that, we can print out a notification to the terminal that we received a connection from, and we can even print out the IP address and the port from which you have received this connection. So for that, we are going to use a format string, so f right here, and inside curly braces, we shall have our values. So this address in itself is a list which contains the IP address and the port, and so I'm going to have the first index, which will contain the IP address, and the next one is the port, which is the second index. That out of the way, in the next video, we shall enter the loop in which we shall continually take input from the user, send that to the malware, and receive back our results. I'll see you there. Welcome back. So I'm going to create a loop that is an infinite loop, so while true. And inside the loop, according to our plan, we are going to start by taking input from the user. Now for that, we are going to use the input function, which can have a prompt, and I'm going to use a $sign and a space, and I'm going to store that in an inp variable. After that, I'm going to create a separate variable called cmd, which will basically be inp plus a new line character. And the reason for this, in case you're wondering why we need two variables, is this. So since you're going to be handling various kinds of commands that we expect from the user, we shall use the inp variable for that comparison. However, what we are going to be sending back to our malware will actually be the second variable. If you can recall from the previous section, our malware expects input from the server until it encounters a new line character. Therefore, every command that we shall be sending from our server has to end in a new line character so that our malware will know where to stop and continue with its actions. In the next one, we shall get into a series of if-else statements in which we shall handle the various scenarios, and I'll see you there. Welcome back. Now for a start, we are going to handle the queue or quit command, which, if you can remember from the previous section, was for closing the connection. So for that, we are going to have an if statement that compares our inp variable, the lower function to convert it to lowercase, and check whether it is equal to either queue or quit. And if the condition is true, of course, the first thing that we are going to do will be to send our cmd variable to our malware. So we are going to do con.send and pass in our cmd variable, but encode it. The reason we are encoding it is that any data sent over the network has to be in bytes format. Once we have sent it, we can now receive a response from the malware, and I'm going to store that in a resp variable and use the receive function. And you're going to supply a buffer size of 1024 bytes, and since it is in bytes format, we'll have to decode it. Now once we have the response from our malware, we can simply print it out to the terminal. And then since this is a quit command, which is basically for closing the connection, let me add the comment right here. we can also terminate our server script. So exit with an exit code of 0. And that is it, guys, for this command. And in the next one, we shall handle the screenshot command. I'll see you there. Welcome back. And in this video, we are going to be handling the screenshot command. And for that, we are going to have a simple check, which will be a comparison of our INP variable, in lowercase of course, with a screenshot string. And if the condition is true, then of course the first thing will be to send our CMD variable to our malware. And after that, I'm going to create a variable here called b64_string, which will be an empty string for now. And before proceeding, if you can remember from the previous section, what we were doing after taking a screenshot is that we were sending back a base64 string of the file's contents. So in this case, we are simply going to be receiving that string, then decode it and write it to a file. Now, since this is going to be a large response, we are going to have another loop right here in which we are going to continually receive data from our malware and then append it to our b64 string. So we are going to use a TMP variable right here and receive data. And once again, since this is going to be a large amount of data, I'm not going to work with just 1024 bytes. Instead, I'm going to use a larger size, say 32 kilobytes, which as you can see right here is 32,768 bytes. So I'm going to have that number right here. And of course, decode it. And then after that, we are going to append it to our b64 string. And since this is an infinite loop, we need a condition that if satisfied, we are going to terminate. So what I'm simply going to do is keep checking our temp variable whether or not its length is less than the 32,768 bytes. So if the length of the TMP variable is less than 32,768, then we are simply going to break out of the loop. And once we have done that, we can now proceed to decode the base64 string and write it to a file. Now I'm going to do that in one step. So I'm going to open the file, which I'm going to call screenshot.png, since it's a PNG image. We are going to open it for writing in binary. And we are going to use the F function to write to it. Now for writing, since we are doing it in binary, right here we are going to use the b64 decode function. So let me fix this right here. It should be with open. And back right here, we need to use a base64 decode function that will return the bytes content of the file. So for that, I'm going to import something extra up here from the base64 module. So from base64, import b64 decode, which is the function that we shall be using. So right here, you're going to have b64 decode, and inside the brackets, you're going to have b64_string. That is it, guys. And in the next one, we shall handle the download command. I'll see you there. Welcome back. Now, before working on the download command, there is something extra that I would like us to add right here, and that is a simple notification to the terminal that the screenshot has been saved successfully. So screenshot saved successfully. And that is it. And now for the download command, if you can remember from the previous section, the syntax for that is download space followed by the file name. And so for the check, we are simply going to split our INP variable into two, that is using a white space, and then we are going to compare the first value to the download string. So let us do that. So INP.split using a white space, and we are going to take the first value in lowercase and compare that with a download string. Now, if that is true, of course, the first thing to do will be to send our CMD variable to our malware. And after we have done that, the rest of the steps are going to be very similar to our screenshot command above. So I'm going to create a new variable right here called b64_string, which will be an empty string. And after that, we are going to have a loop to continually receive data from our malware. So I'm simply going to copy what we have up here and then paste it here. And the reason for that is that in both cases, we are going to be receiving a large amount of data from our malware. Now, once we are done receiving the data, we can do one of two things. Now, our malware was to respond in two ways to the download command. One is whereby we provide a file that does not exist, maybe because of a typo, and the response to that will be a file not found string. So we are going to start by checking for that. So if not found is in the base64 string variable, then you are simply going to print it out, base64 string, and continue. So the continue keyword will basically take back control to the start of our loop. The other case is whereby we actually provided a correct file name and we get back a base64 string of its contents. Now the format for that was file name followed by a colon, then a base64 string of its contents. So the first thing that we are going to do will be to split our base64 string variable into two, using the colon as a separator, and store the results into variables, so file underscore name and base64 underscore string. After we have done that, we can now simply decode this string and write it to this file. So with open file underscore name, for writing in binary, we are simply going to write the results of the base64 decode function on the base64 underscore string. And that is it, guys. In the next one, we shall work on the upload command, which is basically transferring a file from our server to the malware. See you there. Now, before handling the upload command, I'm going to add a simple line right here, which is a notification that the file has been saved successfully for the download command. And once that is done, we can now proceed to our upload command, whose syntax is simply upload space followed by the file name. Now, if you can check up here, you can see that these commands are very similar, and so the check is also going to be the same. So you're going to split the inp variable using a white space, take the first value and convert it to lowercase, and compare that to the upload string. Now, if that condition is true, the next thing that we are going to do is to grab the file name. So it should simply be inp.split using a white space, and this time picking the second value, which is the file name, and we are going to strip it of any trailing and leading white spaces. We are going to store that in a variable called file name, and once that is done, the next thing that we are going to want to do is to check if the file exists. Now the reason for this is that we might have made a typo and end up looking for a file that does not exist. So we're simply going to use the os.path.exists function. So remember to import the OS module up here if you do not have it. And we are going to provide the file name right here. So if not, that is if it doesn't exist, then you're going to simply print out that the file does not exist. Else, we are now going to proceed to read the file's contents, convert it to a base64 string, and send it to our malware. Now the format to send the data is simply file underscore name, followed by a colon, then a base64 string of the file's contents. So the first thing that we are going to do is to read the file's contents, and I'm going to create a variable for that right here as an empty string, and then we are going to open the file for reading in binary, and we are going to save those contents in the file content variable. However, we can simply just encode it in one go right here. So base64 encode. So this is the opposite of the base64 decode function, and this function now takes the contents in binary and converts them to a base64 string. So in the parentheses right here, we are going to pass the contents of the file, so f.read. And once we have done that, we are going to proceed to combine the file's contents with which is the file content variable, which is a base64 string of the file's contents, with the file name. Now to do that, I'm going to create a new variable called tmp, and we are going to use the join function, so.join. So we are going to join both of them using a colon, and the join function basically will take a string right here containing the file name as the first argument, and the second one will be the file's contents. Now, the base64 encode function returns bytes, and we are going to want a string right here. So I'm going to cast that into a string, file content. And also, we are going to add a new line character right here, because if you can remember, our malware basically reads commands from our server until it encounters a new line character, and then it can proceed to execute the commands that it has received. This should be str and not string. And so the next thing is to send this to our malware. So you're going to do con.send tmp.encode as we have done several times before. And once we have done that, we are going to receive a response from our malware in order to know whether or not the file has been uploaded successfully. So we are going to store that in a resp variable, and we are going to receive 1024 bytes and decode that. And once we have that, we are going to simply print it out, and that is it. So in the next video, guys, we are going to finish up by handling shell commands and the others. See you there. Now for this final section, we are going to handle shell commands, the persist command, and any other kind of command that we might send to our malware. So I'm going to have a simple else, and in here, we are going to send our cmd variable, as we have done many times before. And we are going to save the get back the response from the malware and save it in a resp variable. Now, I'm not going to use 1024 right here, and the reason for that is that different commands return different kinds of responses. So for example, the who am I command will return a simple response, or rather a short word, while a command like ifconfig will return a long response. So I'm going to make this big, so maybe 32768, just to make sure that regardless of the response that we receive, we'll be able to store it all in the resp variable. And once we have received it, we are simply going to print it out, and that is it. So in the next video, guys, we will now have a chance to test both our malware and our server together. See you there. Congrats on getting this far. It is finally time to test out all the work that we have done up until this point. So with me here are two windows, and on one I'm going to be running the server, and on the other the malware. However, there's a small bug that I want us to fix right here, and that is for these two variables right here. They each need to have their own pair of curly braces. So I'm going to close this one right here and open another one right there. Once you have made that fix, we can now execute our malware and see how it goes. So let me start the server, and the command for that is python3 space server.py. Hit enter, and as you can see, it is listening for incoming connections. And on the other window, we are going to start our malware. Now, first of all, we turn off the Go 1.11 module feature with Go 111 module equals to off, and then go run main.go. Hit enter, and as you can see, we receive a connection right here on our server's terminal. Now we can try the who am I command, and we get back the username of the currently logged on user. We can try pwd to give us the current working directory, and it works perfectly fine. We can even try ifconfig, which will give us the network information, and we receive the entire message. Now that is shell command execution, and the other feature our malware has is to change directories. So we can try to use the cd command to navigate, for example, one directory up. So cd .. and let us check where we are. And as you can see, we have moved one directory upwards into the desktop. Now, let us try to capture a screenshot and see whether or not it will be captured and sent back to our server. So the command for that was screenshot. Hit enter, and we get a notification that the screenshot has been saved successfully. So let us check the location of our server, and as you can see right here, we've gotten a screenshot.png, the exact same time, so it has been captured right now, and as you can see, the command works. Now, the other capability our malware has is file download. So that allows us to transfer files from our target machine to our local machine. So let me navigate to the malware directory, pwd, so we are there, and doing a file listing, we have our main.go, which is the actual malware, and the plan.txt. So I'm going to test out the download feature with the plan.txt and see whether or not it will appear on our server side. So I'm going to hit enter, and we get a notification that the file has been saved successfully, and checking right here, we have it. So we can open it, and as you can see, these are the plans that we had written before developing our malware. Now, the other thing is file upload, which is the opposite of file download. So we are basically going to try and transfer a file from our server to our malware. So for that, I'm going to create a simple test file. So I'm going to simply create a test file. And as you can see, we have it right here. And so I'm going to try and use the upload command to move it to our malware. So we don't have it right here, but I'm going to do upload test file and hit enter. and we get a notification that the file has been uploaded successfully, and looking right here, we have the file. The other thing that you want to try out is the quit command, but before that, I want us to try out persistence. So the command for that was persist, hit enter, and guess what? We get a success notification here that persistence has been established successfully. And finally now, for the Q or quit command, which is supposed to close the connection and terminate our malware. So I'm going to do quit and hit enter. And as you can see right here, we receive a notification closing connection, and our malware on the other end terminates. So as you can see, all the features in our malware work as expected. In the next section, we shall look at next steps that you can take to improve our malware, as well as the conclusion. See you there. Finally guys, here is the conclusion. So here are some next steps that you can take after having developed your own remote access Trojan using the Go programming language. So the first thing that you can try out is to port the malware to Windows, and the reason for that is that Go is a cross-platform language, and most of the code that we have written will actually work on Windows with little to no modification. So in our case, for example, the only major change that you will have to make will be for the persistence function. So for Windows, one way to achieve persistence, and actually the commonly used one, is to use registry keys, and that requires admin privileges. The other thing that you can try out is to make the malware modular. So what I mean by that is that you break down the program, the big program, into smaller programs that each perform a unique task, and then have them all work together. That is it guys, and I would like to thank you all for following through the course to the very end. I wish you all the best in your endeavors, and goodbye.